In our last video, we looked over solving equations with substitution. So we found one variable um, kind of on its own as a whole other expression and just plugged in that expression, solved for the other variable, and then solved for the first one again. In this case, we'll be using elimination. So we're going to literally take our two equations and be able to eliminate one of the variables, get rid of one of them, so that we can solve for the other variable. And then again, plug it into one of our equations and solve for the other variable. So in this case, a special note, if you are looking at elimination, you need opposite coefficients in front of either x or y to eliminate one of the variables. All corresponding terms must be lined up, including the equal signs. Sometimes you'll have to multiply one or both of the equations by something to get the opposite coefficients you need if you're going to eliminate the variable. So what that means is if you're going to try to add or subtract the equations together, the number in front of the x or the number in front of the y has to be the same before you can start getting rid of them. So let's look at our first example here. If we have our two equations, x plus 2y equals 10 and x plus y equals 6. Now, I can line them up right away and just do a subtraction problem. And I'll show you what that looks like. First, let me get rid of our negative signs here. So it would just be x plus 2y equals 10 over x plus y equals 6, and just call that a subtraction problem. That would give us x minus x equals 0, 2y minus positive y equals 1y, and 10 minus 6 equals 4. We can say that's where we got all of those pieces from. 1y equals 4, or we can just simplify that to get rid of that, y equals 4. That's how we would solve for that one. Now, you may have to use multiplication, and this is what that would look like. If I took this equation here, our second one, and multiplied it by negative 1, it would become negative x minus y equals negative 6. Okay, and that's where I got this piece from. So the negative x plus negative y, this over here we had the minus y. That's the same as saying add negative y. So negative x plus negative y equals negative 6. Now instead of making it a subtraction problem, it's an addition problem. We're adding our two equations together, but again we get the same result. We have no x's left, or just 0x, or just 0. 2y plus a negative y, or 2y plus negative 1y, means we're left with just 1y, or again we can get rid of it and just say y. And on the right side, we just have the constants 10 and negative 6, and those add together to become 4. So we figured out that y equals 4. Again, now that we know that one of our variables, the y variable, has to be 4, we just plug it into one of our equations. Again, I'm using this second one, x plus y equals 6. Well, if y is 4, then that means x plus 4 equals 6. Again, I just plugged that piece that I knew back into the original. From there, I can subtract 4 from both sides and just say that x equals 2. So I have my two spots there, the two places where, or the x and the y value where these two lines will cross. So we'd say my solution is 2, 4. Okay, and again, it's always a good idea to check these. So we plug our values into the original equations. If we look at our first one, x plus 2y equals 10. So 2 plus 2 times 4, 2y equals 10. 2 plus, well, 2 times 4 is 8 equals 10, and 2 plus 8 does equal 10, so this one checks out. First one works. If we look at our second one, give us some space here. If we have x plus y equals 6, so I'd say 2 plus 4, just plugging in my x and my y value, equals 6, and that does check out. So our first one and our second one, they both go through the point 2, 4. They both have a spot where x is 2, y is 4. So that would be our solution. In this case, we're going to be using elimination again, but before we can eliminate, we need to multiply both equations by something. And that's okay to multiply both of our equations. Sometimes you might only have to multiply one of the equations, but it's okay to multiply both, even if it's not the same number. And I'll show you what I mean by that. So in this case, we have our system of equations. 2x plus 3y equals 12 is our first equation. Our second one is 5x minus 2y equals 11. So again, with elimination, I set them up one above the other, line up all of our x values, our y values, the equal signs, and our constants on the other side. Now, we can notice already that nothing matches up. Okay, 2 and 5, 3 and negative 2, 12 and 11, nothing really matches up. So that doesn't necessarily help us. Now, looking at our pieces, though, I notice if I look at our x values, 2 and 5, well, I can get those both to equal 10 really quick. I just have to multiply the top equation by 5 and the bottom equation by negative 2. That way, they'll both equal 10x, and I can kind of get rid of them. I'm multiplying the bottom one by a negative, so that it would be negative 10x. And when they add together, they'll cancel each other out. So when I multiply the top equation by 5, like I said, it becomes 10x. 5 times 3y becomes 15y, and 5 times 12 becomes 60. So that was our new version of the first equation. The second equation then, if I multiply everything by negative 2, 5x times negative 2 is negative 10x, this piece here. Negative 2y times negative 2. And again, that's why I changed this into an addition problem, 5x plus negative 2y. Kind of keeps this straight, that it's negative 2y times negative 2. Well, a negative and a negative is positive. 2 and 2, or 2 times 2. That's where we got this 4y. And 11 times negative 2 is going to be that negative 22. So that's where all of the pieces from our equation, or equations, came from. So now that we have our top and bottom equations, we have 10x plus 15y equals 60. And we put that over negative 10x plus 4y equals negative 22. Well, again, we kind of just look at it like an addition problem, one big addition problem. And we work just from top to bottom. 10x plus negative 10x became 0. 15y plus 4y became 19y. And 60 plus negative 22 just becomes 38. Now, we can notice already we have a 0 plus something. Our x's kind of cancel each other out. We really don't need that 0, so we're just looking at positive 19y equals 38. That's our new equation. And I'm actually going to move that over here, give myself a little more space to work with. 19y equals 38. From there, if we want to solve for y, we're just dividing by 19 on both sides, and we would get y equals 2. So we solved it for we solved in this case for our y value. We'd say y equals 2. So again, to find our x, we just need to plug it back into one of our other equations. In this case, I chose the first equation, so 2x plus 3y equals 12. Plugging in 2 for y, you get 2x plus 3 times 2 equals 12. I can simplify this 3 times 2, or the 3 times y. It's no longer a y term, it becomes a constant term, just 6. So now it's 2x plus 6 equals 12. I can subtract the 6 from both sides. I would get 2x equals 6. And dividing both sides by 2, I would get that x equals 3. So again, our solution is the spot 3, 2. That's the only spot where both of these lines are going to cross at the same time. Now again, it's always a good idea to check these out, plug them in. So if we looked at our first equation here, and we have y is 2 and x is 3, we would say 2x, or 2 times 3, plus 3y, or 3 times 2, equals 12. And simplifying these, 2 times 3 is 6, plus 3 times 2 is 6, equals 12. And in fact, 6 plus 6 does equal 12. So that one does check out. That one works. For our other one, if we're looking at 5x minus 2y equals 11, so we can work with that and say 5x, or 5 times 3, plus 2y, or oops, minus 2y, and y was 2, equals 11. Okay, so we just plugged in our values to check them. Again, simplifying, 5 times 3 is 15, minus 2 times 2 is 4, equals 11. And again, in fact, 15 minus 4 does equal 11, so that one checks out. So for both of our equations, the spot where they'll both go through is 3, 2, for that coordinate point. X is 3, y is 2. For our last example, we are looking at what's, again, it's kind of a spoiler alert, I should say, that it's an inconsistent system. And I'll show you what that looks like in the case of just solving algebraically. So again, we have our system of equations. We have the two equations, negative 3x plus 5y equals 12. And we have 6x minus 10y equals negative 21. Like before, over here I set them up one over the other. Doesn't matter which one is on top. We just have our two equations. Again, like our last example, we're going to need to multiply to get these to be in a case where our x and our y, or at least one of those, will cancel each other out. So for our top equation, I'm going to multiply it by 2, because again, I noticed that negative 3x, we can easily get that to a negative 6x just by multiplying by 2. That negative 6x would cancel out with this 6x. So this one doesn't have to change at all. Just keep it just as it is. So the top equation becomes negative 6x plus 10y equals 24. Again, because I just multiplied everything by 2. The second one didn't change, so we just keep it at 6x plus negative 10y. Or again, our original one had minus 10y. I just changed that to an addition. Called it adding a negative 10y equals 21. So we have our two equations set up one over the other. Again, it just becomes an addition problem. The top equation added on to the bottom. Negative 6x plus 6x becomes 0, or 0x. Positive 10y plus negative 10y becomes 0. Those cancel each other out. And positive 24 plus negative 21 becomes 3. Now in this case, if we were to simplify this side, we would have the equation then 0 equals 3. Now, I don't think that's actually true. I'm pretty sure 0 doesn't actually equal 3. So we have a whole new equation. We solved for everything correctly, but our new equation that we got has an untrue statement that 0 equals 3. Well, in any of these cases, if you get it to 0 equals something, that's going to be an inconsistent system. Again, that means we have our parallel lines. If we were to solve these out in like a y equals mx plus b form, they would both say y equals something x, and it'd be the same number in front of x. They'll have the same slope, but that y-intercept, the b value, is going to be different. Okay, so we have 0 equals something shows that they're going to be an inconsistent system with parallel lines. If we were to solve it out and we found that 0 equals 0, in that case it would be a consistent dependent system, or the same line. If you can solve it out and you find that 0 equals 0 using elimination, again, that means that your two equations are actually the same exact equation. If you subtract an equation from itself, the same equation from itself, it'll give you 0 equals 0. So that one would be a consistent dependent system, or the same line. Again, in this case, we found that 0 equals something, 0 equals 3. So ours is actually an inconsistent system with parallel lines. There is no solution to this. So that'll actually conclude our videos.